Welcome to Brain Vision.
Hi there. In this problem, we have a function n defined as p plus q over p plus r. In other words, if we're going to make a little tree diagram down here as the book does, and n depends on three variables, p, q, and r. And we're also given that each of those depend on three variables, u, v, and w. So p equals u plus vw, q equals v plus uw. Sorry, that was q equals v plus uw. And finally, r equals w plus uv. Okay, and we're asked to find the partials of n with respect to u, v, and w. Also, we're given that u is 2, v is 3, and w is 4. So let's write all this info somewhere. U is 2, v is 3, w is 4. Okay, and actually, as long as we're at it, this info here, just to make things shorter when we go in a minute, we can use that to get our values of p and q and w when we need them. So p, well, it's u plus vw. It's 2 plus 3 times 4, so that should be 14. Q is v plus uw, so 3 plus 2 times 4 should be 11. And r is w plus uv, 4 plus 6 is 10. Okay, so these are all our current values. Now let's get started. So first, partial of n by u. So again, if it helps, we will follow the tree diagram as shown in the textbook, which we might as well finish. Each of p, q, and r depend on those three variables, u, v, and w. So u, v, w. All right. So en by du. We just need to make sure that we end up at u at all branches. So we're going to do the left branch plus this middle branch plus this right branch. So we'll have three terms. So first, we need the partial of n with respect to p. And that means, well, here, let's write what we have. So we need the partial of n with respect to p times partial of p with respect to u. And then we'll do the same thing. And q to u, and then just following the diagram. Okay, so we'll have these three terms. Partial of n with respect to p. We will have to use the quotient rule, it looks like. So let's work over here. So we've got the denominator times the derivative of the numerator, which is just 1, right? The derivative of p plus q, if p is the variable, is just 1, minus the numerator times the derivative of the denominator, which again, with respect to p, is just 1, all over the denominator squared. Okay, good. And by the way, let's see, these p's do cancel out. So really, we just get r minus q on top. And so let's erase this, because we get r minus q when the dust settles. Okay, and we can actually put a value on that because we know all of these values. So r minus q, 10 minus 11 is -1 on top. And on bottom, p plus r, 14 plus 10 is 24. 24 squared. Okay. Good. Now, p with respect to u, for that, we look over here. And we can just, at a glance, we can see that derivative is 1. So we're done with this first term. Okay. Partial of n with respect to q. And so we can, a similar thing. For this one, we actually will not need the quotient rule since there's no q on the bottom. So just at a glance, again, we can see the denominator will stay the same. And the derivative of that numerator there, p plus q, again, is just 1, if q is our variable. And p plus r, again, is 24, 14 plus 10. So we just get 1 over 24. Okay, q with respect to u. Again, at a glance, we can see that this is just, let's see, should be w, yes, right? So the derivative of v plus uw, if u is our variable, is w. And w at this moment is 4, we're given. So we'll multiply it by 4. And finally, partial of n with respect to r. Here, just to make it easier coming up, looking ahead, here's what we'll do. We'll keep this as is, and this was 4. This way we can keep our partial n's that we calculated and not have to do things over again. Okay, so partial of n with respect to r. See, let's quickly use the quotient rule. So you get the denominator. The derivative of the numerator is 0 since there's no r in there. So really we can erase all of that. All right, minus the numerator times the derivative of the denominator, which is 1 with respect to r. So we can leave that over the denominator squared. Okay, and again, at this moment, let's see, p plus q, 14 and 11 is 25. So we get negative 25 on top. P plus r is 24. Okay, so we have partial in respect to r. And finally, let's see, partial of r with respect to u, we can look, and that's going to be v. It's looking right over here. And v at this moment is 3. Okay, so now the rest is just calculations. And let's see what we get. So 24 squared. And actually, at this point, we can, here, let's consolidate things. So we have -1 over 24 squared. If we look at this term here, we're going to have -75 on top, and that's over the exact same denominator, 24 squared. So that'll help us speed things along. And then we have 4 over 24. To get the same denominator, might as well multiply by 24. Which will give us 98 on top. So let's see, -1 minus 75 minus 76 plus 98 all over 24 squared. All right, and if we compute that, grab a calculator, but we should end up with, when everything's reduced, 5 over 144. So make sure that's what you get. And we're done with the first of 3, and the next 2 will be much quicker because we've already done the partial derivatives of n. All right, so now let's go back, and all that's going to change. So now we're going to take the partial of n with respect to v. So all right, let's make that v. And again, all that's going to change are these parts of our calculation. I'm just going to write over these u's with v's because everything else stays the same. So all we have to erase in our calculations were the second factor in each term because the partials of n are the same. Okay, so now quickly, we need the partial of p with respect to v. Now if we look over here, just looking, we have a derivative of w, and w at this moment is 4. So we can fill that in. All right, for q sub v, the derivative of q with respect to v, we can see is 1. So this won't change. This is just times 1. And derivative of r with respect to v. Again, we'll look over here. And we have u. And u right now is 2. Oops. Okay. So these calculations do change a bit, but again, it's at this point it's time for a calculator. So we'll have negative 4 over 24 plus 24 squared plus 1 over 24 minus 50 over 24 squared. So when you compute that, just make sure you should get that reducing to negative 5 over 96. Make sure that's what you get. Good. And now we are done with partial of n with respect to v. So finally, all we have to do is change that v to w's, and then we'll be done. So let's make all of these w's. W, W, W. Okay. And again, all that's going to be erased are those values, and this will be quick. So partial of p by w is going to be v, looking here. And v is 3. Partial of q with respect to w is going to be u, and u is 2. And partial of r with respect to w is just 1. Good. And again, calculator work when we add everything up and reduce should end up with, I believe this is the same one as the first one, 5 over 144. And we're done. Hopefully that helped.